Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in PIST Virtual Learning System Session 2020. Dear students, this lecture is for grade first year boys and girls, and we are on chapter number 3, Central Processing Unit CPU. This is our 15th video lecture, and the subject is computer science. Central Processing Unit. So dear students, today I'm going to talk about RISC architecture, CISC architecture, Pentium 4 processor, AMD processor. Then in the last we will discuss key points of this chapter, and then we will do exercise MCQs. So let's start with the introduction of RISC architecture. The term RISC stands for Reduce Instruction Set Computer. It is a CPU design plan based on simple orders and acts fast. This is small or reduced set of instructions. Here, every instruction is expected to attain very small jobs in this machine. The instruction sets are modest and simple, which help in comparison more complex commands. Each instruction is about the similar length. These are wound together to get compound tasks done in a single operation. Most commands are completed in one machine cycle. This pipelining is a crucial technique used to speed up RISC machine. So dear students, basically RISC stands for Reduced Instruction Set Computer. It is considered new architecture of CPU. RISC architecture of CPU supports same size of instruction, and it does not use indirect addressing mode. The instruction of a CPU that uses RISC architecture are very simple and are executed very fast. RISC CPUs require fewer transistors, which makes them cheaper to design and easy to manufacture. Example of RISC processors are IBM, PowerPC, Sun Sparc, mobile phones, and tablet PCs. So RISC basically are simple system and architecture which you can use in your computer system. It's a reduced instruction set computer is a microprocessor that is designed to carry out few instructions at the similar time based on small commands. These chip needs fewer transistors, which make the transistor expensive to design and produce. The feature of RISC include the following. The demand of decoding is less, few data types in hardware, general purpose registers identical, uniform instruction set, simple addressing, no modes can be used. Also, while writing a program, RISC make it easier by letting the computer programmer to eliminate needles code and stop wasting of cycle. So RISC basically is a simple architecture for the microprocessor which needs the less coding and few data types of hardware. General purpose registers are used, uniform instruction set, and simple addressing modes are used. On the other hand, we have CISC architecture. The term CISC stands for Complex Instruction Set Computer. It is a CPU design plan based on a single commands which are skilled in executing multi-step operations. CISC computer have small program. It has a huge number of compound instructions which takes a long time to perform. Here a single set of instruction is protected in several steps. Each instruction set has additional than 300 separate instructions. Maximum instructions are finished in 2 or 10 machine cycles. In CISC, instruction pipelining is not easily implemented. So CISC stands for Complex Instruction Set for Computer. It is traditional architecture of CPU that supports a large variety of instructions. These instructions may have different length and use all addressing modes and require complex circuitry decode them. CISC architecture is complex because of the instructions used at the hardware level. Examples of CISC processors are the Intel 486 series and Pentium series. So CISC architecture is basically a complex architecture in which many addressing modes can be used, and it's a complex circuitry to decode the instruction. CISC architecture is complex because of the instruction used at the hardware level. The CISC machines have good X based on the overview of program compilers, as the range of innovative instructions are simply obtainable in one instruction set. They design compound instruction in the single simple set of instructions. They achieve low-level processes. That makes it easier to have huge addressing modes and additional data types in hardware of a machine. But CISC is considered less efficient than RISC because of its incompetence because of its incompetence to eliminate codes, which lead to the wasting of cycles. Also, microprocessor chips are difficult to understand and program for because of the complexity of hardware. So CISC architecture is complex architecture, and RISC architecture basically is a simple architecture. So it is complex. CISC is a complex architecture for the microprocessor, and it can use all type of processing nodes and modes, additional data types in the hardware of machine. On the other hand, RISC is a simple architecture design, and the following are few differences between CISC and RISC architecture. CISC instruction utilize more cycles than RISC. RISC stands for Reduced Instruction Set Computer, whereas CISC stands for Complex Instruction Set Computer. The RISC processor have a smaller set of instruction with few addressing nodes. The CISC processor have a large set of instruction with many addressing nodes. So here you can check RISC is a reduced instruction set. So basically microprocessor sometime based on the base of instruction set. So we have discussed instruction set in the previous lecture, how many instructions in instruction set we have: 0 addressing, 1 address, 2 address, 3 address. So reduced instruction set computer, and CISC is a complex instruction set computer. The RISC processor have a smaller set of instruction with a few addressing modes. The RISC processor have a large set of instruction with many addressing modes. So here is a machine instruction, and it can be executed in RISC architecture. Here we have a machine instruction, microcode conversion, micro instructions, then micro instruction execution. So it's a more complex microprocessor, and RISC is a more simple microprocessor. So CISC introduce instruction utilize more cycles than RISC. CISC has way more complex instruction than RISC. CISC typically has fewer instruction than RISC. CISC implementation tend to be slower than RISC implementations. Computer typically use CISC, while tablets, smartphones, and other devices use RISC. So remember that computer typically use CISC architecture, while tablets, smartphones, and other devices use RISC architecture because it is a simple and reduced instruction set for the computer. We can differentiate between RISC and CISC on the basis of the following points. Memory unit. RISC has no memory unit and use a separate hardware to implement instruction. CISC has memory unit to implement complex instruction. Program. RISC has a hardwired unit of programming. CISC has a microprogramming unit. Then design. RISC is a complex compiler design, and CISC is an easy compiler design. Calculations. RISC calculations are faster and more precise. CISC calculations are slow and precise. RISC, then decoding. RISC decoding of instruction is simple. CISC decoding of instruction is complex. Time. Execution time is less in RISC. Execution time is very high in CISC architecture. So dear students, RISC versus CISC. CISC, multiple clock cycles. It can use multiple clock cycle, and in RISC we have single clock cycle. In CISC, any instruction may refer memory. In RISC, only load, store, refer memory. In CISC architecture, not pipelined or less pipelined. And in RISC architecture, highly pipelined. CISC architecture instructions interpreted by the microprogram. In RISC, instructions executed by the hardware. In CISC, variable format instruction. In RISC, fixed format instruction. In CISC, many instructions and modes. In RISC, few instructions and modes are available. In CISC, complexity in microprogram, and in RISC, complexity in the compiler. In the last, CISC, single register set. On the other hand, RISC is a multiple register set. Dear students, now it's Intel and AMD architecture. Intel and AMD advanced micro devices. Both are the primary manufacturers of processor. Intel and AMD both are primary manufacturer who developed the microprocessor for the computer system. So Intel and AMD are the famous architecture and manufacturer of for processor. They make processors for desktop computers, laptops, and notebooks and mobile devices. Different types of processors perform different functions at different speeds depending on what kind of system they run. Each type of processor has different functionality, but similarities do exist among various types. Both Intel and AMD make processors for a variety of systems. Core, Pentium, and Celeron families of processor belong to the Intel, while Phenom, Athlon, and Celeron processor belong to AMD. So Intel is the world's largest manufacturer of PC microprocessors and the hold of the 86 processor architecture patent. AMD Micro Device, AMD, is an American multinational semiconductor company based in Santa California that develops computer processor and related technologies for business and consumer market. While it initially manufactured its own processor, Intel and AMD have excellent processors for gaming and productivity tasks like video editing and transcoding, but they do have their specialized to AMD's top of the line processors. For everyday web browsing, watching Netflix, and answering emails, Intel and AMD CPUs will give you excellent performance right out of the box. There are certain tasks through their one company's option perform better than of the others. Types and characteristics of microprocessor and processor. Features affecting processor performance and compatibility with motherboard. Feature 1, clock speed. The processor support current Intel and AMD processor work with the system buses that run at 1.8 gigahertz up to more than 3.4 gigahertz. Feature 2, the processor speed and processor core frequency is measured in gigahertz such as 3.3 gigahertz. Feature 3, socket and chipset the processor can use. So processor, basically the main function of the processor is to process your instruction, to execute your instruction. Sometime on the basis of its functionality, we can call it the main part of our computer system, because every time it takes the instruction and then process it effectively and it takes the input, it takes the instruction, then convert into the output. Pentium 4. So Pentium 4 is the famous microprocessor. Intel's top Pentium chip introduced in late 2000, the successor of the Pentium 3 chip. It is the successor of the Pentium 3 chip. The Pentium 4 featured the net burst micro architecture. Pentium models go by different names such as Pentium D and Pentium Processor Extreme Edition, all omitting the 4 designation. Available in both 32 bits and 64 bits version with and without hyper-threading. The Pentium 4 was introduced at the end of the 2000 with 1.4 and 1.5 gigahertz clock rate. Speed later reached 3.8 gigahertz, and Pentium 4 chips were first built with 180 process touch technology and subsequently shrunk to 130, 90, and 65 nm. So Pentium 4 processor have 20-step execution process. They have high clock speed and perform fewer operations per clock. Pentium processor generally use 478-pin socket and use megahertz to specify processor speed. So Intel Pentium 4 is no other, and Pentium series is a famous series of desktop computer and the PC computer presented by and manufactured by Intel. So Intel is a manufacturer of processor, and Pentium 4 is a series of your Intel company. AMD processor. AMD is the second largest maker of personal computer microprocessor after Intel. These processors generally 462-pin sockets. AMD processor do not use megahertz. So AMD processors have 10 steps execution. Remember that Pentium 4 processor have 20 steps execution. And in AMD processor, we have 10 steps execution. These processors generally use 462-pin socket. AMD processor do not use megahertz to specify processor speed. This is due to the instruction set handling that AMD use. So this is the comparison between the AMD and Intel manufacturer. So clock speed and the core. Here in AMD, we have 6.3.6 gigahertz, and AMD 5 Intel core, we have 6 multiplied by 3.6 gigahertz. And CPU threads here we have 12, and in Intel we have 6. In RAM speed 2667 megahertz, and it's 2933 megahertz. Here we have level 2 cache 3 MB and 1.5 MB, level 3 cache 16 MB, and here we have 9 MB. So if we will do the comparison on the basis of the price and power consumption. So price cheaper than Intel, and the Intel more expensive than AMD. Power consumption less efficient than Intel, more efficient than AMD. Cooling factor, AMD heats up faster and Intel runs cooler for a longer duration. Performance speed not very fast compared to Intel. AMD is not very fast compared to Intel, and Intel faster than AMD. Gaming and multimedia, in AMD it's good, and in Intel it also good. So both are good for and suitable for the gaming and multimedia. Performance, price good, and performance is good and the price is low. And in Intel the performance is good but the price is high. So these are the differences between the AMD and Intel processor. So dear students, we have finished this chapter, and in this chapter we have discussed the following points. Central Processing Unit, CPU, is a single unit that consists of ALU and control unit, the brain of the computer system. Arithmetic logic unit, ALU, is the part of the computer where actual processing takes place. Then control unit directs and coordinates the activities of the entire computer system. It controls the working of all the input-output devices, storage devices, and the calculation performed by the ALU. So if you remember that we discussed that the CPU is the brain of the computer system, and CPU is further divided into two or three main parts. ALU and CU are the part of the CPU. ALU is responsible to perform all type of arithmetic and logical operation, and the control unit is responsible to fetch the instruction, decode the instruction, and execute the instruction. It will control all the activities inside the CPU. Then we discuss a bus is a group of parallel wires used for transmitting binding information from one part of the computer to another. There are three types of buses: address bus, data bus, and control bus. And when we will combine these three buses, so it is called system bus. The general type of instruction used in computer are data movement, operation, shift, comparison, branch, input, output, instruction. Then we discuss instruction code is a group of bits that tells the computer to perform specific operation. Control unit cycle through the fetch, decode, and execute step till the last instruction of the program is executed. Then in the last, CISC stands for complex instruction set computer that supports a large variety of instruction, which may be as many as 300. RISC stands for reduced instruction set computer that supports very simple, limited number of instructions. So dear students, now it's time to solve your exercise. So here is MCQs. Which part of the computer perform fetch, decode, and execute cycle? Yes, ALU, control unit, output unit, registers. Yes, it's control unit. B, control unit. The second, where are the results of ALU operations transferred? Counter register, base registers, data registers, accumulator registers. Yes, it transferred to D, accumulator register. Which of these buses selects a memory word for a read or write operation? A data bus, control bus, address bus, or system bus? Yes, C, address bus is responsible to read and write operation. Which of these registers control the sequence in which instructions are fetched from memory for execution? Program counter, memory buffer register, data register, counter register. Program counter register. A memory word that is to be stored in or fetched from memory must first to be transferred into which register? Accumulator, data register, memory buffer register, program counter. Memory buffer register. A memory word that is to be stored in a fetched from memory must first to be transferred into memory buffer register. Which instruction caused transfer of instruction execution to a specific address? Comparison instruction, branch instruction, shift instruction, data movement instruction. Branch instruction caused transfer of instruction execution to a specific address. Which of these instructions will perform addition of two numbers? Operation instruction, shift instruction, comparison instruction, data movement instruction. Yes, operation instruction will perform addition of two numbers. Through which bus instruction are transferred from main memory to instruction register? Control bus, address bus, instruction bus, data bus. Data bus. So data bus is responsible to transfer your instruction and data from main memory to instruction register. How many distinct operations can be performed if opcode of a microprocessor of 4 bits? 4, 8, 16, and 32. Then which part of computer decodes instructions? ALU, main memory, program counter, and control unit. So it's control unit. How many distinct operations can be performed if opcode of a microprocessor of 4 bits? It should be 16. 16 instructions can be performed. Now, dear students, it's time to your homework. So you have to write your short question answers on your computer notebook and long question answers also. So part 1 to part 6, you have to write on your computer, register. Then from the long question answers, you have to do part 1 to 3. So dear students, thank you so much. Till next lecture. Allah Hafiz. See you soon, inshallah. Allah Hafiz.